All right, welcome to season 3 of the Little Astrophysicist. This season's all going to be about preparing my daughter for her grade 9 science test. So she got one coming up in chemistry soon. It's not the whole unit, it's the first half. So let's get started. So, classifications of matter. Do you know all these classifications?
Yeah, sure.
Oh, sure. Okay. So we've got mixtures and pure substances. So mixtures have more than one particle. Pure substance has only one particle.
Alright.
Okay, so mixtures, we have mechanical mixtures, meaning you can very clearly see there's more than one thing. Like pizza, you've got cheese, sauce, bread, pepperoni, and they're all visibly distinguishable from each other.
Alright.
Solution means they're all there, but you can't distinguish them from each other. Right? Like sugar water. The sugar dissolves in the water, you can't distinguish it. For pure substances, we have elements, those you can find on your periodic table, like gold. Then we also have compounds. Now, I know in your class you also talked about molecules, right?
Yeah.
Okay, so let's quickly go over the difference between a molecule and a compound. So let's say I have this bottle filled with gas, and inside I have a CO2 gas and oxygen gas. Okay? Now, the oxygen is two elements bonded together, but it's the same element. So this is actually a molecule. Okay, this is also a molecule. So a molecule is just when you have more than one element bonded to each other. However, for it to be a compound, those elements need to be different. So CO2 is also a compound.
Oh, okay, I see,
Okay.
yeah.
So, that's the difference between molecules and compounds. Okay, so essentially every compound is a molecule, but not every molecule is a compound. But then when we put them together in the same canister, this is a mixture. Specifically, it's a solution because they're both invisible gases, so you can't distinguish visibly between carbon dioxide and oxygen. Make sense?
Mm-hmm.
Okay, so what we're going to do, I'm going to give you some different examples, and you're going to place the examples in either mechanical mixture, solution, element, or compound. Okay?
Oh, shucks.
Here we go. That's how we're going to do it. Let's start with lead. It's like the metal, lead. Okay, good. Element. You'll find that on a periodic table. Table salt, otherwise known as sodium chloride. It's sodium and chlorine bonded together. Good. That's a compound.
Yeah.
Okay. Kool-Aid. You know what Kool-Aid is?
Yeah.
Where's that? Good. That's a solution. Vegetable soup. So a soup that has all different vegetables inside of it. Okay, good. A mechanical mixture. How about Coca-Cola?
Cool cola.
Okay, good. Iron. Yeah. How about, here's a hard one, rust.
Hold on.
Good, that's a compound. Do you know what rust is made out of?
No.
Iron and oxygen. So iron oxide is rust. And baking soda. No!
No! Stop!
I'll give you a hint. Baking soda is a, there you go. It's a compound made up of sodium, hydrogen, carbon, and oxygen, but all chemically bonded together. So that's a pure substance. Okay, moving on. Now that we have our cat. Physical and chemical changes. Do you know the difference?
Yeah.
What's the difference?
Okay, so like physical, you can like, see. And chemical is like you mix stuff.
That's your definition.
Okay, you know what? Physical change is a change in size, shape, or state. No new substance is formed. Chemical change is change in the physical and chemical properties. A new substance is formed.
Okay, so, so with a physical change, you don't get anything new.
Okay.
So if I took a piece of paper and ripped it up into tiny pieces, it's still paper.
Okay.
A chemical change, you get a new substance. Now, this can sometimes be confusing to know if you've gotten a new substance, so we do have some hints. Let's go over these hints.
Why is the text so big? Come on.
Well, so you can read it.
All right. What? My eyes ain't that bad. What?
All right, so one hint is a new color may appear. Okay, now, these are hints. Just because you see a new color doesn't automatically mean it's a chemical change. Right? If I put food coloring in water, doesn't mean there's a chemical change. Okay. Hint number 2, you get some sort of change in energy. So heat or light is given off. This is called an exothermic reaction. Have you learned that?
Sure.
Okay, that's a no. Okay. Or heat can be absorbed. If heat's being absorbed, the reaction feels cool. This is endothermic. Number 3.
Man, what are these? Like, come on, make the things a little different, dude. Like different? Quantitative and qualitative. Like you can barely tell. You can barely tell which is the difference. It's one letter change.
Okay, think of we'll get to
I
that
know
in
the
a
difference.
Minute, but...
I know the difference. It's just one letter change, dude. Like scientists need to be a little
think
more
of it like
creative.
This. Thermic is sort of heat energy.
Okay.
Like thermal energy, right? And exo is outwards and endo is inwards. So that's why they're like that. Okay?
X and in.
Exothermic is heat given off. Endothermic is heat taken in.
Okay.
Okay. Another one is gas bubbles are formed, but this is very important, without heating something up. So if I take water and I heat it up on a stove, you're going to get gas bubbles, but that's a physical change, not a chemical change.
Okay.
Okay, so gas bubbles being formed without adding heat to it. And the last one is a precipitate is formed. You know what a precipitate is?
Yeah.
I put a little picture there for you.
Yeah, sure.
So it's kind of weird, but when you mix two liquids together, you get a solid. And it looks kind of cloudy. And
I remember what precipitate is.
There you go. Okay, so now what we're going to do is we're going to go over these examples and we're going to label them as either physical or chemical changes. So let's start with number 1. Salt dissolves in water. Come on, you said you got it.
Let me skip that one. So that's
all right, silver tar. What is going on? Okay, good. Apple being cut is physical. Heat changes water to steam. Okay. That would be chemical. Good.
Yeah.
We are skipping a lot of these here.
No, I don't know. Okay, hold on. Let me dissolve in the water.
50-50 chance. No, it was the
Oh my god! Okay.
Okay.
Erase that.
Don't.
Oh!
Hold on. Let me do the erasing here. Because you erase, like, everything. Salt dissolving in water. So, I'll explain what happens here. Okay, when you put salt in water, it does something called dissociate. So the sodium chloride splits into their ions like this, right? You don't get anything new. They just split into their ions and are inside of water being dissolved. So because there's no new substance produced, that's a physical change. So anytime you dissolve something, physical change. Because there's no new substance.
Okay, so that means... If you say no, I swear to God.
No. That's also physical.
What does tarnish mean?
Tarnish is... You know what rust means?
So like rust.
It's not... Rust we only use for iron. Okay, for all other metals that combine with oxygen in the air, we say tarnish. So it's combining with oxygen in the air. Yes. Okay. You get something new. Chemical change.
Heat changes?
So water.
Pee?
Yes. Do you know why?
Because it's heat?
Because it's still water.
Okay.
If you change ice to a liquid, it's still H2O. If you then heat that to a steam, it's still H2O.
Alright.
Okay. Yep. Iron rust is chemical. Alcohol evaporates. This is just like number 4. Number 8's just like number 4 as well. A change of state is a physical change.
Oh, okay.
Okay, because you're not getting anything new.
Milk sours. Ew. Come on, get rid of that milk.
Milk sours. Physical or chemical? Chemical.
Okay.
You can tell that new odor that is produced is a hint that you have a chemical
How does
change.
wood rot?
Just over time.
So physical?
Mm.
What does that mean? Chemical?
Chemical. You get something new.
It's physical, right?
Nope.
Oh my God.
When you cook something, pancakes is hard to tell, but think of eggs. When you put an egg in, right, that clear substance turns white, right?
What?
When you're cooking an egg?
Because it turned white, all of a sudden it's chemical changes?
Well,
but
it turning white's a hint that it's a chemical change.
But
you got something new.
What?
Yeah.
Physical?
Close.
Oh my goodness gracious me.
You need to create new materials if you're going to grow. Tires inflated. There you go. Food is digested.
That uses acid, right?
Yeah.
Yeah. Okay.
Paper towel absorbs water.
Pee?
Yes, that would be physical.
Man, that was so easy.
Yeah, I could tell. Okay. We're going to practice more of that later ourselves, but for the video, let's move on. You have changed units, right?
What?
Unit conversions?
Oh, I know these.
Hold on.
These
Let me just explain it a bit. So this is our metric system. Let's do an example. If we're going from kilograms to grams, so kilograms is here. Grams is our base unit here. So if we're going to the right 1, 2, 3 times, each movement is an order of 10. Right? So if we're moving that to the right 3 times, we're going to move our little decimal to the right. 1, 2, 3. So that gives us 450 grams. Make sense?
Yeah.
Okay, try C.
Oh, my bad. So that?
Yep, centimeters.
To meters. So
meters.
1.
Where's meters? Meters is our base unit.
But that's an M. Wait, where's meters?
Meters is base. It has no prefix to it.
1, 2?
Yep. Where's the decimal? The decimal's not there. There you go.
Okay.
There you go. 4.79 meters.
Wait, I got the other ones.
Okay, do E. So liters, again, liters has no prefix in front of it, so it's our base unit.
What's a prefix?
A prefix is like like all these little letters, deci, centi, milli, micro, nano, and so on. Right? And then our base unit is what we're measuring, whether we're measuring grams for mass, or meters for length, or liters for volume. Okay, so we're measuring liters for volume, and then we're going to milliliters. There we go. Let's do one more. Let's try G. Grams to kilograms. Perfect.
Oh my god, I'm awesome.
All right. We'll let everyone else do the rest and tell us the answers in the comments, and I'll make you do it later.
What?
But last, density. Okay, what's density?
Mass divided by volume.
Yeah, that's certainly how you calculate density. What's mass?
The amount of space takes up space.
That would be volume.
Okay,
Volume is
what?
how much space something takes up. Mass is how much stuff there is.
Nuh-uh.
What do you mean, nah? Right? If I had a container, right? That's a certain amount of space in there. So that container has a certain volume, right? And then I throw stuff into the container. The stuff I put in there has a certain mass. And then how spread out that mass is inside of that volume is density.
Oh, whoa, hold on. I was told different, you see?
What?
Look, so here's a table. Okay? Artistic ability. Okay? You see the table?
Yeah.
This square takes up a certain amount on this table.
Yes?
Yeah. Now what? How much is mass? That's mass.
Okay, but that is some sort of stuff, right? So that's mass. How much space it takes up is volume.
Okay, dude.
Don't say okay, dude.
I remember hearing something else.
Let's say I have a cup of water.
You do have a cup of water.
I do have a cup of water. No one else can see this, but I have a cup of water.
Okay.
Okay. Now, how much water can fit in this cup would be its volume. How much I could fit inside of it.
Okay.
But if I then put in a certain amount of water and put it on a scale to see how heavy it is, that's telling you its mass.
Okay.
Well, how heavy it is force, but we'll get to that when we get to grade 11 physics. But the amount of stuff is mass, and how much space it takes up is volume.
Okay.
Okay. So that's the formula. Density equals mass over volume. Think of it like this.
Looks like a little rocket ship.
If you had something that was very, very dense, would it sink or float?
In what?
Water. Good question.
It's very, very dense, so it'd sink.
It would. So remember when we did scuba diving?
Okay.
If you're floating on the surface, are you wanting to inflate or deflate your BCD?
Inflate?
Inflate, right? Because it makes you less dense, because air will take up a lot of volume with very little mass.
Yeah.
Okay? Okay. Now let's get back to this. Question 1. So we know the equation for density. Can you rearrange that and tell me how would you solve for mass?
Oh, let me see. Hold on. I'm thinking.
Okay.
Okay. Cut this part out so I sound smarter. Okay.
Continue.
Okay.
No.
Oh my god.
That's okay. Here's what we're going to do. I can show you 2 ways to do this. One way is the important way, which is important for our math skills. So if we want to, math terminology here, if we want to isolate from mass, meaning we want to get it by itself, we need to figure out how to bring volume over to the other side of the equation. So what you do is you look at what volume is doing to mass and you perform the opposite operation. So in this case, volume is being divided by mass.
Okay.
So the opposite operation would be to multiply by volume. And whatever you do to one side of the equation, you do to the other side as well. So that cancels out volume, and you get mass equals volume times density.
Oh, okay.
Now this is a trick I showed to grade 9s. Only to grade 9s because it only works with very simple equations like this. I don't do this in grade like 11 or 12. But this is our density triangle. So what you can do, if you want to solve for mass, okay, you can cover up mass with your thumb and then look at what you have left. Density times volume.
Oh.
However, if you wanted to solve for a density, sort of cover up density, and what do you have? Mass divided by volume.
And mass divided by density is volume?
Exactly. All right, write that volume equation. So what does volume equal? Excellent. The only thing I really want you to do is to help with our math skills. In high school, we're not going to use that anymore. Everything's going to be written like a fraction. So it's going to be mass divided by density. Okay?
Okay.
Okay. Now that we know this, let's start a problem. You've done problem solving. Do you know what the grass method is?
I know the grass method.
Same thing. It's just P means paraphrase, or the last S in grass is?
I don't know, like...
Sentence.
What?
So we've got...
No, it's supposed to be statement.
Statement. Okay. Same thing. They're all synonyms. Okay.
Then why are they different words? So, explain that.
So we've got given. What's the R?
Require.
There we go. A?
Answer. Analyze.
S?
Solution.
Yeah. In this case, I have a P, which I usually just say paraphrase. But you can have sentence, or what was the one you said?
Statement.
Statement, yeah. And that last one is important. So grasp or grass is a way to show your work, because it's important showing your work. And when you're doing a problem-solving question, it's essentially a question in translation. So the question is in English. You'll change it into mathematics. And then when you get an answer, you'll state your answer back in English.
Okay, wait, let me do this.
So let's start by reading it and writing the given. So we have a 25-gram sample. So what's 25 grams?
25 grams.
Is that mass, volume, or density?
Grams.
Grams is mass, volume, or density?
Oh. Mass.
Mass. Okay, so let's write M equals 25 grams. Okay. Of wood has a volume of 40 centimeters cubed. Okay, so.
If you say it's not volume, I'm gonna flip out.
No, that's
it
volume.
says volume.
It's pretty obvious. You can also look at the units to help you tell what it is. Determine the density of this wood. So we want to know density. So required. So you're gonna write D equals. And what's the equation?
Okay. So D equals 25.
I want you to write the equation first. Don't substitute yet. This is me being very picky as a physics and science and math teacher. Yeah, you're not listening.
What? I thought I was doing what I was supposed to do. What are you talking about?
Yeah, you are. That is completely correct.
So what am I?
But two things. One, I want you to write the equation first. M over V.
Bruh.
The reason is If you substituted incorrectly, you will not get any marks for knowing the equation. But if you write d equals m over v, you will get part marks for knowing the equation. It's showing your work. Then we're not going to go horizontal like this. Math is done vertically, not horizontally. So we're going to go down. D equals like so.
Okay.
Okay. Now you can grab my calculator. I know it's not yours, so...
It's not turning on.
It is on.
Oh.
25 divided by 40.
Oh.
Equals. Execute.
Where's the...
Okay. Yeah, that's a fraction. So we're going to change that. Good. And what's the last step? Good. Statement.
Hey, that looks like your G.
Thank you. All right. So, side note, will that sink or float in water?
Oh, that will float.
Good. All right.